Hey guys, welcome to Safi Mixed. In this video, I want to prove that the Poisson distribution, which describes the probability of a random variable, is normalized. That is, we know from the definition of Poisson distribution that the probability of a random variable n equals n bar per n divided by n factorial exponent minus n bar. Here n in this relation is a random variable, n bar is the mean of the random variable, and we want to prove that this probability for the random variable is normalized. That is, if I sum this relation over all the possible values of random variable n, then p of n equals sum over n equals 0 to infinity n bar to the power n divided by n factorial exponent minus n bar, and we want to prove that this goes to 1. So one thing we see here, the exponent is in fact independent of the summation parameter, because here appears the average of the parameter, which is constant for a particular experiment. Then I can write this thing equal exponent minus n bar sum over n equals 0 to infinity n bar to the power n divided by n factorial. And if I look into this thing, it is simply the Taylor expansion of the exponent of n bar. That is, this thing is in fact equal to exponent n bar. And if I replace that value here, I write minus n bar multiplied with exponent plus n bar. And since these are numbers, therefore I can put them into a single exponent. That means I can write this minus n bar plus n bar. And minus n bar plus n bar goes to 0. Therefore, it is exponent 0, which is equal to 1. That means the sum of all the possible probabilities for all the possible outcomes equals 1, and that's what we call normalization of Poisson distribution. So the Poisson distribution for the probability of a random variable is normalized. Thanks for watching.